Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is James Avery, founder and CEO of Kevel, previously co-founded TechPub, and The Lounge and Ruby Row. Welcome, James.
Thanks for having me.
So, James, before we kind of get into the meat of things, would you give our listeners a little introduction to yourself? Tell them how you got started in the industry.
Yeah, absolutely. So, like you said, I'm the founder and CEO of Kevel. Previously, I was a software engineer. So I got started kind of in the .NET space, was a Microsoft MVP, all those things back in the day when .NET was first starting. Like I was one of the first people to use the ASP.NET beta way back. When was that? 2004 or something like that, or earlier, 2001. And then was an independent consultant, worked for a bunch of large companies, and then kind of found my way into the advertising space by starting The Lounge, which was actually it was like the original .NET developer network, working with people like Scott Hanselman and Phil Hack and a lot of the kind of old school .NET Microsoft guys.
So how did you come to, I guess that kind of introduced you to, or brought you to Kevel. What are you doing here? So you founded Kevel and you're the CEO. What is that like for you?
Yeah, I mean, it's amazing. Like I started out, I think like a lot of engineers, I was looking to build something that, I was tired of writing other people's code. And I was looking to say, how do I build something? How do I sell it myself? How do I build a company? And I started that, 10 years ago at this point. So it started as just me building all the original code and launching it. We raised a little bit of money, hired some more people, started, I was sales for a while, started hiring salespeople, hiring marketing people, and like scaling the company up. And so we're about 50 people now and work with a lot of great companies like, Ticketmaster and other, pretty top tier companies.
So I would imagine that you probably don't have your hands in the code then on a day-to-day today, or is that still the case?
My commit, like, what do you call it? I'm not allowed to commit code anymore. Trying to find a more diplomatic way to say that I got kicked out. But yeah, I think it was after the time that I made a change, committed it, pushed it up, and then the build failed because I didn't even run any tests or compile anything before I did it. So I got revoked. But yeah, I still am involved a lot on the product side and just, once an engineer, always an engineer. I can't help but get in there with our VP of engineering and some of our principal engineers and discuss, architecture and how we're going to build things out and things like that.
Cool.
So, as mentioned in your bio, this is not your first foray. Kevel is not your first foray into a company. One of the companies in the list that I was extremely familiar with was TechPub. I used to love TechPub. I subscribed to it the second I saw it, and just want to say to you and Rob Connery, if you ever talk to him anymore, thank you. Because I would not be where I am now if TechPub had not existed. TechPub was more important to me than Pluralsight and a whole bunch of other stuff. So, on that though, TechPub probably had to have a decent amount of scalability because you've got thousands or maybe hundreds of thousands of people coming in and watching these videos and everything else. How did you guys handle scaling that up?
Yeah. So, TechPub was great. Working with Rob was great. We never had, I don't think we ever had hundreds of thousands of people, but I'll take the thousands. But yeah, it was great. It was really a testament to, cloud technology, right? Like what we did was we kind of went and figured out how to build it on Amazon and how to do a lot of these things where we were hosting this stuff on CloudFront. We were, you could remember with TechPub, you could actually download the videos, which nobody else still does to this day, I think. Or you could stream them, and we figured out how to basically live stream them through CloudFront. And it was just Amazon scalable, right? Like I think the amount of actual hard tech we wrote was a handful of like back end, scripts to be able to like upload this stuff, like render it and upload it to the right spot. And then it was like a simple website. And we rewrote the website like 4 times because every time Rob wanted to do a video on like a new tech, he's like, I'm going to rebuild the site using it. So it's like, it started out in like MVC, and then it became like Ruby on Rails because he wanted to do one on that. And then I think it went back to MVC with like one of the newer releases. And so, all the tech for TechPub was rebuilt like 3 times.
Yeah, I do remember some of those videos.
He'd always forget to add back in, like, because I did a lot more of the marketing. Like if you went to a user group back then, you would get like a card, for like a free class, and like we would take them to all the different conferences, and I'd have to go, like, he'd rebuild it for the class, and then he'd be like, but I didn't add back in like your coupon code or any of the analytics. So then I'd have to like go download it and get it running and code in all the coupon coding and analytics and the things that like weren't, part of the main flow of the app.
So that's really nice that you were able to lean on the cloud as much as you were able to. It feels to me like the ability to do that is changed over the years, though. Like many companies are dealing with issues where scaling out isn't, like, you can't scale up far enough. Scaling out is becoming more and more difficult because, I don't know, we hit a phase and we're like, oh, microservice everything, and so the applications are even more complicated than they used to be because they're really just large interior applications spread over across the network. How are you dealing with that kind of stuff at Kevel? Are you in the current trend of breaking everything into microservices, or are you approaching things differently to maintain scalability?
Yeah, I think at Kevel, the scale we have to deal with is, it's billions and billions of requests a day. So, very high numbers of requests a second. And essentially like conventional architecture and how you would build a, enterprise app, which is what I used to do, all of that breaks down. Yeah. Like I can tell you the original version of the, ad serving code way back for the lounge, 10 plus years ago, was like, it just called a select against a table, and the table had all the ads in it, and it decided which one to serve, right?
You can't do that anymore?
You can't do that anymore. Maybe with, you could probably pay some company enough money to make your database scale to that, but like you're not going to run a profitable business paying that much. But yeah, so on the kind of the scaling out part, right? Like I think what a lot of people don't realize is that most apps, when people start to scale out, they scale out part of the application and not all of it. And so they leave some bottleneck in there. Like I remember a talk I was seeing a long time ago. I can't remember who it was, but he was kind of talking about this scaling of an application and how, you have an app server, and the app server can auto scale in Amazon, and you're really proud of your ability to auto scale. And then he'd say, well, do you have a queue? And you're like, yeah, we use RabbitMQ. And it's like, what does the queue auto scale? And it's like, no. And so you don't really, you have one part of your system that can scale out, but you haven't built that scale out functionality into everything. And going back to the microservices piece, we don't, I would say certain parts of the system, we use microservices, but in the parts that are highly scalable, the approach we actually take is something I like to call every engine is an island. So what we call our servers that kind of do the main part of handling requests and impressions and clicks, we call engines. And the idea of every engine as an island is that it can literally be that box that gets drywalled in somewhere, and it will just run by itself for 10 years if it doesn't get rebooted. Because every external dependency is just another, PagerDuty alert waiting for you. To crop up. So those are pretty self-contained. They have all the data they need to continue to serve. They write all their logs to disk, right? So like a lot of people, when you think about impression data, the disk is your friend. You can write a lot to the disk really quick. You can then ship those files around. And the only danger, right, is like if it does have to talk to external services to get updates, right, of like what changes are to pacing and things like that. And if that goes down, then that data will get stale. So it's like an island with a limited amount of food supplies, right? It's good for a while, but you're gonna need need a shipment at some point.
So for our junior devs, what's a pager?
Oh, pager duty. Oh yeah, pager. Okay, yeah. Somebody mentioned that the other day that pager duty needed to change their name because the millennials or Zoomers coming up won't understand the reference.
Like tweet duty, just waiting on a tweet from a specific user.
Yeah, so I think before we hit record, we were talking about Kevel, and you gave the quick little elevator speech describing what it is and what it's for. Do you mind just refreshing our memory of what that was?
Yeah, absolutely. So essentially, the way I like to talk to developers about it is that we're Twilio for ad platforms. So we see lots of companies are building really innovative ad platforms, right? When you look at Twitter and how they're doing advertising, or Pinterest, we want more companies to be able to build really good ad platforms, ones that are good for users, good for advertisers. And so our APIs make it a lot easier to do that. The part, we tackled the hard part of, building a really scalable architecture. And so we can leave up to the developers the part of integrating it into their platform, figuring out the right way to show these ads, figuring out how to optimize them. So that's really what Kevel is, if you're in a place like a marketplace or a travel company where there's a really good opportunity, you can build that ad platform without having to build everything from scratch.
Yeah, and I think most of our backgrounds are more of line of business applications, enterprise level applications, and we think about scaling. To Clayton's point earlier, I think we think about scaling, and to your point as well, we think about scaling as spin up or increase CPU or RAM on the app server, or increase the performance on the database or something like that. So we're thinking about enterprise level architectures maybe a little bit differently, maybe breaking out microservices that can scale or scale up or out. But you're talking about a scale that is pretty unheard of in that line of business type application when you're talking about billions of requests per day. So what are the differences when you are designing an application for scale at that scale?
Yeah, I mean, I think like a lot of the big differences, right, is like I used to write those enterprise line of business apps, and you do still have to do scaling work, but I think the big difference is that in enterprise apps, I feel like a lot of times when you're working on scalability, a lot of it is optimization, right? Like when I would go into these companies and they would have something a bunch of people wrote and it was super slow, and we'd go in and we'd look and we'd say, oh, you guys, your indexes are all wrong in SQL Server. You're returning 7,000 rows and filtering them in memory, right? Like it's lots of those kind of things that like get that app to the right level. When the stuff that we're building, a lot of times you can't fix it just by optimizing those things. We still try to, right? Like it's always the cheapest way to do it. If it always goes back to so many times developers want to focus on that performance and they feel like they're failing if they like double the size of the box. But that is 100% almost always the cheapest thing to do, unless you're using like Oracle, right? It's just say like, it's like, oh, we need to make this run faster. And you're like, oh, we're on a 2X extra large on Amazon. And it's like, well, do we solve this problem by just making it a 4X? Because the company will gladly pay another $300 a month because they're going to pay you that in a couple hours, and you probably aren't even going to fix it in those couple hours. So throwing hardware at it is tried and true, still always a good idea. But then I think the difference is that there are these architectural differences and things that just go out the window. Like you can't talk to your database on every call. You can't assume that you can write to a queue at this speed. Like we used to try to do that for a lot of events, is write them to a queue. And it just becomes a fire hose that can be really tough to maintain if anything breaks down and pulling off that queue. And that's where we found that writing to disk was sometimes the best option.
So yeah, I was going to wonder, so do you switch to something like a different technology, or do you just break the problem down differently? So, yeah.
Yeah, I think it's mainly architectural. Like I think that there are some technologies that work better than others. for things that are highly scalable, but I'm convinced you could write it in any language, right? I mean, there's very highly scalable Java applications. There's, Shopify is using Ruby still, or Facebook is using PHP. Like the stuff can be done. It's all about that architecture of really limiting these bottlenecks and figuring out ways to make it so that parts of it can go down or parts of it can slow down. And we have, thousands of Amazon instances running. So at any given time, Amazon is trying to kill one of those instances, right? Like just the odds are not in your favor. And so you can't have a system where it's like, oh, we have, in the enterprise line of business, you might say, oh, we got, we have our database and RDS, or we have a cluster of 3 app servers. And it's like, your odds are pretty good. You're not going to get reaped. But like the odds increase a lot when you have thousands of these.
So like John was saying earlier, at the your standard enterprise level, when there's something slow in the system, it's the database, or it's this inefficient code, and you can use metrics and determine what part is slow, and then go try to enhance that. But at the level that you're at, how do you even find what's the next thing to try and change in order to achieve the results that you need to achieve? Like, how do you know that you need a queue, or how do you know that you need scalable queues, or to write to the file system?
Yeah, I mean, I think some of it still comes down to profiling. So we still profile our code a lot, because that is still the cheapest way to improve performance, right? Is to look at where are we pulling too much data out. We use Redis a lot, like on the machine, right? Because like we limit that network hop by putting it on the machine. If we're pulling back too much data from Redis, that increases memory pressure, puts more, we go through more data in memory. So like there's still those optimizations still make sense. But then when you're looking at like the architectural side of things, of saying, well, I don't want to call SQL Server, I don't want to call like a relational database here. What are my options, right? And so then you start to figure out like, okay, well, let's, what if we call Redis or Memcache? And then you say, well, even that network hop really slows things down. So like, what if we put Redis on the machine? Okay, but then do you have to duplicate all your data on every machine? Well, okay, now I need to figure out sharding, right? Like, how am I going to shard my data to the right machines that need that data and not the ones that don't need it? And so one little decision of saying like, okay, well, we don't want to scale up SQL Server or Oracle or whatever to this level, then leads you down the rabbit hole of, okay, how do I build this architecture out this way?
Sounds awfully complicated.
It is very complicated, but it's very fun. And I think, you tend to, there's developers that really want to work on that type of stuff. And I think they just end up gravitating towards these really complex distributed systems. And those are the people we try to hire.
Right.
Yeah, I thoroughly enjoy adding only the necessary complexity where possible. So, starting with a basic application, like I said, line of business developer, our stuff is usually pretty boring. We're looking to, minimize repeated calls to databases. So we might introduce some caching mechanism, maybe Redis cache, something like that. So it sounds like those types of optimizations are at least similar across the board when you're looking at something in the hyperscale that you're looking at. I'm wondering if maybe, without going into any trade secrets or anything, divulging too much information, I'm wondering what a typical request looks like in an application like Kevil, maybe even something in the back of your head. How might you design something for that type of immense scale that you're looking for?
Yeah. So, I mean, the interesting thing is like we're at scale, and we also have really low latency requirements. So we have to make these calls in under 50 milliseconds, or 50 to 100 milliseconds. You have to return which promotion or promoted listing like you should show. So that's the other really limiting factor, right? Like if you had a lot of time, then there's probably things you could do differently than the way we did it. But I think the kind of key thing, so if we think about an ad request, that comes into our API, right? And we're mostly on Amazon. So, it comes into a load balancer. It gets sent to a machine running Nginx. The servers are mostly written in Node. So it makes a call into the node process that then calls to Redis, right? So Redis has this local version of the data that it needs, right? And then it finds the data it needs, and then it does a bunch of operations around filtering and targeting and auctions. And some of that happens in Redis, some of that happens in the code, and that's kind of part of what we optimize. Like it can actually change a lot based on the data set. Like that's one of the hardest things about optimizing, right? Is like you can go write an application and it's very optimized for a certain data set, but then customers start doing something different, right? Like, like a line of business app, you come in and you say, oh, well, there's only 6 items in this drop down. That's fine. They call you back a year later and they have like 24,000 in that drop down. And you're like, how'd you guys do that? Like, what's going on? So same sort of thing. Like it has to kind of constantly change sometimes based on the data shape and like how you optimize it. But one thing you said about caching that I think is a really good point that comes up a lot is that caching, especially in enterprise apps, caching really a lot of times is like on kind of an LRU cache, right? Like you're saying, I'll check the cache. If it's not there, I'll call the database. Yeah. Well, at scale, you cannot do that because what happens is you DDoS your database if all your cache gets cleared. Because everything might be running fine because 99% of your requests are hitting the cache, but then let's say your server restarts, or let's say all your servers restart, right? And then now suddenly every server, hundreds of thousands of times a second are trying to call your database, and it's just going to fall over, right? So you have to switch caching to really be push based. And so what we do is we actually push things into the cache. It's not reading, like that system can never read it back out of the source. The source is actually looking at changes. So we have basically a arbiter, right? That's like sitting in the middle saying, okay, I'm watching for changes in the source data. And then I'm pushing those out to the cache for them to go live.
So do you have some kind of watchdog process in the background that invalidates cache when it knows it is necessary and repopulates?
Yeah, so like the push can be either invalidation, like it can remove something or it can add something, right? So it's really just kind of removing and adding constantly, like it's like thousands of times a second. Like it's kind of ridiculous. You wouldn't think things change that much, but there's a lot of pacing logic and when if something's serving too quick or not quick enough, for all the rules that customers can set up.
Yeah, this is really interesting, and I guess it also, we've been talking mostly about the scaling on the like actual operation of the application, but when you start to add all this complexity, how does your dev team scale? And how are you building, splitting things up in such a way that things can be built and deployed and sort of done independently, but need to be kind of orchestrated in this nice big gigantic orchestration?
Yeah, it's complicated. It's like building teams, like that's one of the challenges, right? Is as it gets more complex, the idea of having one engineer who can understand everything from the UI that the customer is interfacing with, or our customers interfacing with, to the back end of that system, to the middleware, to the delivery engines, and then you have reporting, right, where we're pulling in all this data. It really becomes impossible. Right. Like I don't think there's anybody at the company anymore who, knows everything in the stack. Right. Like there might be some people that have been around for long enough that they're like, I could send a pull request for that, but they're not going to know all the details of it. Right. So you start to end up organizing around some of these seams in the system. Right. And so when you look at like the front end, the UI and kind of what we'll call like the management systems, where you're saying this is where we're, the customer's inputting what ads they want to show or what promotions they want to show. And then there's that seam of like the middleware that then pushes this out to the delivery side. Like that's a good natural split to say, well, we're going to have some engineers who are focused on the delivery, which is the really highly scalable, piece of it that needs to handle these, hundreds of thousands of requests a second. And then there's the side that's working more on the, the UI and the management systems, and they just have a different skill set, right? Like maybe they're really good at UI and they're really good at building nice interfaces, but they're not going to go build this back end very scalable code. And I think they're both just as hard, right? Like it's not like one's easier. And then same with reporting, right? Like there's There's engineers who are really good at saying, okay, we're going to deal with terabytes of data and like figure out how to splice it up and make sure this all scales. They're not the same people who are going to build the highly scalable system or the front end. And then you have a lot of work around orchestration, right? If you want to build a feature that goes across all three of those, right? You have to figure out what's the right approach to that and where does it start.
How does that grow? I mean, because when you started Kevel, I mean, were you guys? You obviously you were the one who started it, right? But now you've got a large team behind you, and you're not even in the code anymore. How quickly did that process take place, and like what were some of the challenges you ran into as you sort of stretched in that way?
Yeah, I mean, I think the biggest challenge is really just the coordination between these different teams, right? Because you can keep making more teams because there's enough subsystems and different parts, right? And you can even like, you can split up the UI and say like, okay, you're focused on this parts of it versus this other team is focused on this other part. But it's just the overhead that gets created is the orchestration between them, right? So it's like if we want to add a fairly simple feature, it could require, changes to the UI so the customer can like click a checkbox, right? Like the simplest change imaginable, right? But now that has to get back to it has to go back to the database. And then it's like, well, the middleware has to pick that up and be able to push it to the engines. The engines need to be able to look for that and do some behavior based on that being checked or not. And then maybe we want to report on it. So it has to get round trip to the logs, which the reporting team needs to know to pick it up and put it into that. So, and then you can just start adding that. And so it's really interesting because it is like not unique challenge, but it is a challenge, right? Of like, how do you build those kind of features that cross all of them? And one of the things we've learned is that because like we're an API first company, one of the things that's helped us is to always focus on like build the API side of it first. So sometimes if we can just focus on, let's just build the API part of it first. We don't have to bring in the UI yet, right? Mm-hmm. Let's prove it works from the API. We have customers who only use the API, never even log into the UI. So like they'll become the early adopters. And then from the reporting standpoint, one of the other really good things to do is to really loosely couple all these groups. Mm-hmm. And so we can add extra data to our logs and ship it to reporting. And they don't look at it, right? If it's not something they're looking for, it's just extra data. It just makes their files a little bit larger. And then down the road, you can say, hey, we'd like to report on this. And we've been sending you that data already for 6 weeks. Mm-hmm. And they're like, great, we can turn that on. And so it's really making sure that you can make these kind of changes without breaking the contracts and APIs like between the different teams.
Yeah, I imagine there's a fair amount of communication and coordination that needs to happen to ensure that this great grand new feature is both implemented correctly and realized by the client and all those concerned, so that everybody gets the value that you would expect that they need out of it, right?
Yeah, well, and I think it definitely, having more people like slows things down some, right? Like it's going to take a little bit longer for some things. So something we did recently was we started a team just focused on developer experience. So we developers are a big part of our customer set. That team is building things like SDKs, right? But then they'll also, maybe while they're building the SDK, they find something that's kind of an annoyance in the API. Well, we said, you know what? They shouldn't have to go coordinate that with that team. If they know how to fix it, they should be able to send a pull request. So you can kind of start to try to mimic some of the like open source mentality like inside the company by not really making it rules. Now we wouldn't want that person just like make the change, commit it, and like deploy the other team's system, right? Like that's a little bit worse. But being able to send a pull request, it's like great. That team can review it, commit it, get it out in a release.
Yeah, and I imagine being an API first company and looking to make your SDKs full featured and usable and valuable to your clients and your customers. I imagine you get really great feedback from those folks that are utilizing these great software features that you're delivering for them.
Yeah. I mean, the SDK has been fascinating, right? Like, I think it's something we kind of waited too long to build because everybody's like, oh, it's they're just some REST APIs and things like that. But the SDKs make it a lot easier to get started, right? Like having something wrapped up and kind of being a little opinionated on how to use it, like, is really helpful.
Mm-hmm. Well, Do you have any resources that you could direct our listeners to people that are maybe dealing with applications at scale or scaling up, whether that is from the application sort of dealing with some of these architectural issues, or whether that's dealing with teams and growth and whatnot?
Yeah, it's a good question. I should have prepared something. I might have to. Maybe I'll share some stuff with you all to include in the blog post or something like that.
Okay, yeah, we can do that.
Yeah. All right. So, what has been helpful in your career that you might share with those just getting started or those looking to level up their own careers?
Yeah, I think for me, probably the best decision I ever made was becoming a consultant, which I know, like in the developer space, right? Like it's usually a kind of a separate group sometimes. But I pretty quickly I worked at a couple companies, and then went to a consulting company, which eventually got acquired by Avanade. So like the kind of big Microsoft consulting company. And it was fascinating how quickly I got to learn by moving to projects like fairly quickly, like getting really exposed to other projects. Sometimes I would be on a project for, 2 or 3 months, right? It was just like, like throw an extra body on it, which is one of the anti patterns of consulting, right? But you get to go learn like a whole new architecture. You get to learn like all these stuff, and you don't really do a lot because you spend 2 months learning and then like a month writing some code. But like you get to learn a lot as a developer. And then I went independent as a consultant. And I think that's even more interesting because you get to learn how to run your own business, and it really changes your perspective when talking to business owners. Like one of the biggest things I see with developers a lot of times is when they're talking to, the business side, right? Mm-hmm. Is that a lot of times the developer is really in the mindset of like, this is the code I want to write, or this is the code, how I think the code should look. Or what do you mean that you told me this last week, right? And they're in this mode of like, I'm just taking orders. And you're always going to be frustrated if you're just taking orders, right? If you're just working at McDonald's, like I worked at drive-thru as a kid, right? It's not fun, right? You're just taking orders all day. And when you get to the point where you're like, I'm going to really learn what the business is trying to do. Like I'm going to participate in this process of business needs and how does software solve it? And to me, like that's when you become a senior engineer, right? Like there's engineers I've met who are, 60 years old and they're still like a regular engineer, right? Because they just want to take orders. And to me, it's like when you really can say, you can go to the business and understand like, oh, okay, I understand now. Like you guys are shipping out 10% of the wrong product because it's hard to pick the right product in your UI. Let's figure out how we solve that, right? Like, let's figure out how we make it the dropdown not have 60,000 items in it. Like, let's figure out how we solve that problem. Like, that's, I think, when developers really level up to a different level. And that's when businesses will pay you well north of 6 figures, right? Because you're providing like business value.
But what do you do when they say, shut up and take these orders?
That's when it's never been a better time to be an engineer looking for work. And I think it's really funny. Like I've interviewed a ton of engineers over the years, and I think a lot of times the engineers who end up doing the best are the ones who are like, tell me about your business. Like what are the challenges you guys are facing? And the ones who usually don't do as well are like, what language do you use? What's your, like what kind of hardware do I get? What's the tool set, right? Because you're really thinking in like, are we selling Whoppers or Big Macs? And it's like, what I want to know is like, what's the goal of the company? What's the software? Yeah. What's the business objectives for this software? Mm-hmm. And when you start to dig into that and then understand, like, do I want to work for this company? Like, is it an interesting problem? Versus, if you have no interest in it and they just want to give you orders, then it's like, hey, like that's, nothing wrong with that. But it's not going to, like, I think, unlock you to that next level of really having an impact.
Absolutely.
So where can our listeners to go to follow you or, find out if you guys are hiring or something?
Yeah, we actually are. We are hiring. We're hiring right now. So if you go to, it's Kevel, Kevel.co. We have a careers page there. We're hiring engineers. And then I'm Avery J on Twitter.
Cool.
All right, chat, hang out real quick. We're going to wrap up the recording of the podcast, and James was kind enough to let us twist his arm into sticking around and ask and answer a few more questions. And so we'll be respectful of his time. So if you've got something specific you want to ask of James, just let us know, and we'll address it in chat. Otherwise, hang tight. We'll wrap up the podcast here. All right, James, thanks so much. Really appreciate you coming on the show.
Absolutely. Thanks for having me.
That was James Avery. James is founder and CEO of Kevel, previously co-founded TechPub and The Lounge and Ruby Row.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And catch us live each week on Twitch. And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
Apparently my voice is cracking.
And I'm James Avery.
It happens to everybody, John. Don't worry about it.
It's all this gray. I
Comes
guess.
a time in a young man's life.
Yeah, one thing we didn't get to was the DevOps story. Ash has been in the DevOps world for a while now. We were all together as mainly .NET developers with JavaScript front end stuff, and Ash has been in the YAML pipelines world recently. Do you guys what's the story like for introducing your changes? Once gone through QA processes, gone through pull requests, gone through code reviews, do you use a lot of automated pipelines, automated testing strategies, or?
Well, this is one of the interesting things, is that it's really diverged among these separate teams. And that's one of the things we've been trying to figure out. How do we bring the best practices of each to the other teams? So some of them do kind of a classic, swap out of instances. Like, it's all AWS. So mostly we're rolling new AMIs and spinning up new instances, as opposed to deploying to instances, that are already running. Which we found is just a best practice, right? Like, deploying in place is always a little sketchier, because you end up in some state that you're not sure of.
Yep.
And so in some systems, usually the ones with very large numbers of servers, we actually try to build it so we can do a rolling deploy, right? So we can slowly roll out new instances and have the old ones get kind of shut down by Amazon. I'd say pretty much the standard practice, but it is a little divergent across teams. And there's some teams that have more automation, other teams it's more a bunch of scripts, but we're working on trying to bring that together.
And these are mostly Node and Nginx, you said?
Yep. Yeah.
So it also is that I got the impression that these are like VMs. Or is that those are, or have you guys does containers break down, or have you guys even looked at that kind of technology?
Yeah, we don't really use containers much. They're all just instances on Amazon. I mean, instances are already VMs, and so it's
Sure.
I just feel weird. It's throw containers on there. You put containers in your containers too.
You can.
You got to box it up. If you don't
Just
put it in a
because-
box, it's just
Just because you can, Ash.
Well, and I feel like containers do come about when you have lots of small services that don't themselves need a lot of resources.
Yeah, sure.
We have a hard time finding something that doesn't need a handful of real servers, and so we just tend to usually stick with them.
No, I think that makes entirely sense. Yeah.
Yeah, I'm just amazed though that your description and your definition of putting the things you need in Redis and not actually reverting back to the database if it's not there. But the database is the source of truth. I don't know.
Yeah. Well, it's still the source of truth. You have to have when you do this mode, the danger is always does it get out of sync? Do things not push out? And you have to have tools to say well, what if we need to recreate the whole thing?
Yeah.
What if we just have to be able to recreate it all from scratch? So you have to build a lot more of that kind of stuff to be sure of if every cache in the world in all of our servers probably isn't going to go down, but if it does, we need to be able to recreate it from scratch.
Yeah. Yeah. And I can only imagine trying to, for reporting purposes, trying to hit the same data store for the sub 100 millisecond requirements and maybe sub 10 milliseconds if possible.
Yeah, well, and that's where the
latency.
file system is really a great friend. Like, I feel like it really lost, like, went out of vogue for a while. It was like, oh, don't write stuff to the file system. Write it to, write it to a queue or write it to something else. But you know what's always there, who's always your friend, is that good old hard drive. And when you're dealing with Amazon, it's not like it's a hard drive, right? It's like EFS. It's actually a networked system. So it's like you're not as worried about loss of data and things like that.
So, have you actually run into any kind of performance issues where somebody came back to you and was just like, we can't because the speed of light?
So, no, not yet. It does come up, right? Because like we have customers, a lot of them call us server to server. So they're calling us from their servers. And so they want our servers to be as close to their servers as they can. So we run in a bunch of different regions in Amazon around the world. But then every once in a while, we have a customer who is not on Amazon or Google Cloud or Azure. And they're like, oh, our servers are in Indianapolis. And we're like, well, like, this is as close as we're going to get to. Like, we're not going to go, there's no AWS Indianapolis. And so it's like, the closest is like the Ohio region, right? And so you say, okay, well, like that's, you're going to have a little added latency because you're calling, across.
So I suggest you move your servers to Cincinnati.
Yeah. Because the interesting thing we found though is like on Google or Azure, like all their data centers are so close. Like the pipes between those centers are so good that like the speed, like if you're calling from like Google East to like Amazon East, like the latency is almost the same as calling within Amazon East.
Yeah, my wife used to work for a web hosting company that was physically located on the same block as hospitals, and they had trunks coming in for major network or internet backbones and stuff. Like just the amount of data throughput that they could get through that building was just amazing.
Oh yeah, well, and they're all kind of in these, like, it's wherever like power's cheap or where there were a bunch of data center hosting companies before, like, so they kind of tend to be in close regions.
Yeah.
Well, we actually had to do that before that. We didn't have to deal with the speed of light, but some guys on my team are way smarter than I did. We're basically like modifying all the like settings in Linux for like how it's sending data across the wire to like speed up sending large amounts of data across the wire. Like, there's like packet sizes and all that. I don't know. It's deeper than I can get, but they definitely did that at some point to improve performance, like across, especially sent into like Southeast Asia and things like that.
Compiling your own kernel.
Yeah,
we haven't done that yet, I don't think.
We found a new compression algorithm that we're using to encrypt the data and shrink it, and then
yeah. Everybody we hire now is smarter than I am. So,
well, that's what I think. A lot of people have said that's the path to success on, especially small companies, startup companies, young companies, is ensure that you're hiring people smarter than you so that they can do bigger and better, that you don't have to worry about doing it all yourself. You can pass it off and know that it's in good hands.
Yeah, absolutely. And just the things that, some people we've hired, like the experience they have and the systems they've built, like they just bring new things that I never would have come to like organically, right? As developers, I think we always think like, if I just bang my head against this long enough, like it'll become perfect. And then somebody comes along and they're like, what did you think about just turning it this way? And you're like, oh.
Shut up, leave my room, don't talk to me ever again.
Yeah, I could iterate on this and get to where you are in 12 years.
Right.
And tell me the cool thing that never would have occurred to me.
Yeah. And that's one of the things I love about like the engineering community, right? Like I've never, like being more focused on the business side now, and people share knowledge, but not like in the engineering community. Like everybody in the engineering community like wants to work with more junior devs and help them get better and create videos for them and create podcasts for them and things like that. It's a very generous community.
Shoot, sometimes I want to work with the junior devs so I can learn something.
Yeah, exactly.
They get into some weird stuff, and it's really cool sometimes.
Yeah.
Yeah, they have all that time, right? They can go home and do this stuff.
Yeah, which reminds me, we're hosting the stpete.net meetup on the Six Figure Dev channel on Twitch tomorrow night.
Oh, that's this week.
It is this week. So we've got a Uno presentation tomorrow, so stay tuned for that. But yeah, we love our dev community. We love the junior devs. I like Clayton mentioned, I'd learn from them as much as I could hope to teach them. Working with the local code school here in town as well, trying to keep in touch. I was actually just contacted. I was telling the guys, one of the junior devs that we hired at the small consultancy that we worked at many years ago together. I went and did a mock interview at one of the local colleges and interviewed this lady, and we ended up needing to hire someone, so recommended that she come in and interview, and we ended up hiring her, and she's taken a position with a rather large international consultant firm now. So continuing awesome. Learning, growing, and doing the stuffs. So what's next for you, James? Any more upcoming exciting things you want to share?
At this point, I feel like it's I like to talk about like the flywheel, and you're just pushing the flywheel. So it's just a lot more of pushing the flywheel. We've been working on some like exciting updates. Not ready to talk about anything yet, but in kind of taking scaling even to like the next level, right? Like I think one of the interesting things to think about is like regions. Like when you get into working in regions across Amazon, like how do you optimize that? How do you make that more efficient? How do you make it so you can serve from all of them at the same time? Like things like that are a fun challenge.
Yeah, I wonder how much do you exploit the functionality that AWS gives to you? Because I know that so many companies out there say, oh, we want to try to remain cloud agnostic in case we want to switch from AWS to Azure or Azure to Google Cloud. So we want to use Terraform and we want to use Docker, and we don't want to rely on the specific services that the cloud vendors, the cloud providers, offer.
Yeah, it's when we first started, my goal was that, which is to stay totally independent of all of that. But it really harms you for like a little bit of future functionality, right? It reminds me of kind of when everybody was getting like pattern crazy, right? And they're like, oh, we're going to build this pattern for talking to our logging infrastructure, because one day I might want to change from this logging library to this logging library. And you're like, dude, like you're adding complexity for something that will probably never happen, because you're probably never going to touch this code again. Like you're going to be gone or whatever, and like somebody else might have to deal with it, but it's like a low probability. So a couple of years ago, or more than that, like we started to use more of what Amazon has built on top of it. But what we tried to do is stick to the services that are pretty ubiquitous across all the cloud providers. So like there are some very like unique specific things on Amazon. We don't tend to use those as much, but things like Dynamo, right? Like if you're using Amazon, you're not using Dynamo, like you're losing a ton of value, because it's the service that half of their stuff is built on. And so, but it's like if you wanted to move to Azure, if you wanted to move to Google, like they have a Dynamo-like service, right? They have a fast key value store that you can use. You might have to change up your code a little bit to talk to it, but it's not going to be, you're not missing it. But when it gets to then there's like all the other, there's tons of other Amazon services that are, much more specific. We don't use a lot of those. Same with like Redshifts, another one where, you can use Redshift or RDS, and it's like those, every cloud host, every cloud system has a way to host a database for you, or has something like BigQuery or Redshift or.
Mm-hmm.
Very cool stuff. Yeah, like you said, all the cloud providers have a core set of offerings that more or less are on, have parity across them. But then they have the differentiators. I wonder how many are thrilled with those and adopt them and utilize them, and how many take the approach that, if we use them, then we can never move. We're going to be tied to them. And then there are those that maybe are choosing to be multi-cloud and say we can use Azure Functions here and use something AWS specific for another purpose.
Yeah, that's always, I mean, I guess it's depends on the type of company, right? Like I could see maybe some like large enterprise companies doing that. But if it's a startup, like, man, that's just over optimizing, right? Like just pick one. Like you're not going to be successful based on which cloud provider you pick, and you're not going to fail based on what cloud provider you pick, right? Like it's kind of like programming languages, right? Like when I was in the trenches, it'd always be, oh, this language is better than this language. It's like, look, like you can build a successful business with literally any language, right? Like there's very successful banks still running on like COBOL, right? Like it's not the language that's going to make or break you, right? It's like that's how you can translate that business problem into code. And you can do it in lots of things. Now you might really not like writing in certain languages, and that's fine to have a personal preference, but to pretend that like, .NET is more successful than Java, is more successful than Ruby things, like there's no evidence to that.
But Go and Rust are.
Yeah, but Go and Rust will solve all your performance issues. They won't. There's always a cool new language, right? Like if you were, 10 years ago, Ruby was the cool new language that solved all your problems. Then it was Node and JavaScript, and now then it was Go, and then it's Rust. I guess Rust is newer than Go in the language stack here.
Yeah, I don't even know anymore. I try to keep up. I try to be at least aware these days, but I find, like you mentioned earlier, I'm much more interested in making sure that I understand the business problems that we need to solve and figuring out ways to solve them. And if a way to solve them is with a pencil and paper to that guy, then I'm going to give that guy a pencil and paper and not really worry about introducing Kubernetes and
right.
But can they scale?
Databases.
Can the pencil and paper scale?
Does
they
it
can
need
when
to?
they need to.
And they did for like 2,000 years. Yeah, totally. And I think and like developers also, like we all love to learn, right? And like, so we want to learn a new technology. Like I'm as guilty as anybody else when I was an engineer to say like, oh, you know what? Like this problem, I'm going to take this opportunity to learn this new technology to solve the problem. But like, I think like, my thing would be like engineers, like also take that love of learning and like transfer it to like these business problems. Cause they're a lot like coding problems. They just have more people and more people telling you the wrong thing and untrustworthy narrators, but you get through all that. And they're very similar to the systems problems you deal with.
Yeah. Like 5 or 6 years ago when we all worked together, I think SignalR was the big thing. And I was wanting to find a reason to use it. I wasn't going to force it onto a project or onto a client, but should the need arise or have arisen, whatever, should there have been a need, then I was ready and chomping at the bit, and then a need came and I was tied up, and one of the other developers got the chance to implement. Like, but I've been waiting so long.
You've never gotten to do it, right?
No. It's happened like 2 more times after that since as well, that there was another opportunity 2 more times, and I was still not the one that was available to implement.
I will say that's a great use for side projects though. Like side projects are a fun place to try stuff out.
He can't
Unless you're trying to make it a real business, then don't do that.
He hasn't found a valid reason to use SignalR in his side project. He doesn't want to force it on his side project.
Yeah, I'm not a resume-driven developer, even on my own time.
So you play in both parts. You're like the engineer. You're like, we should use this, and then you're like the business analyst. And you're like, I don't think that we need that for this business problem.
Yeah, write up a use case, and then we'll talk about it in our quarterly finance meeting.
Oh, good stuff.
Well, this has been great. Chad, if you've got any additional questions, we'll start to look to wrap up here. We want to be respectful of James's time. It has been a pleasure. So James, want to be sure to thank you. We are looking to publish the podcast in about 2 weeks. So I don't think we spoke about that before. So James, unless you've got something you'd like us to coordinate the release with, we're looking at Monday, March 22nd.
Yeah, it works for me.
Okay. With that, we will be back on the Six Figure Dev channel hosting the stpete.net meetup tomorrow at 7 p.m. Eastern. So please be sure to join us here for that. And then Wednesday evening at 8 p.m. Eastern, we'll be back on for live coding for some personal projects. Maybe we'll make some progress on Clayton's Blazor game engine, a port of monogame in Blazor.
Woo.
You're welcome. I just volunteered you. And then we will be back next Monday, 6 p.m. Eastern for the live recording of the podcast. With that, we'll say good night, everyone. Thanks for joining us. Be sure to like, subscribe, and follow along. And say, of course, again, good night to James. And thank you so much. We will raid our friend Vimmark over on Twitch.
Good night.
See ya.
Awesome.